Happy Wednesday, you guys. Please go ahead and take out your composition notebook and follow along as I explain the topic for today. I'd also like for you to copy the I can statement, and that is I can solve and graph one-step inequalities by using inverse operations. Okay, so let's go ahead and get started. Here's our first example. Our first example is 9 plus x is greater than or equal to 5. So this is a simple inequality. So step one, we're going to start with what we know. We know that we need to isolate x, and it's very similar if you guys think back to what we did with equations. We solve them the same way, but the only thing that's different is our inequality sign. And remember, let me just refresh your memories. An inequality is some number that may or may not be equal to another number. So we're trying to figure out what that number is, and let's see if that's a true statement, right? We're trying to make that a true statement. So here, we're going to start by using inverse operations. I subtract 9 on both sides, and I get x is greater than or equal to -4. Pretty simple, straightforward, okay? Remember, you cannot graph if a variable is not isolated. So just as you see it says 9 plus x, x is not by itself, so I cannot graph this until I've got x by itself. So that brings us to step 2. We're going to go ahead and take that -4, and there's two things we need to do for step 2. We need to determine what kind of circle we're using. Again, if you refer to Monday's notes, we use either an open circle or a closed circle. And in this case, we're going to look at our inequality, and that is a greater than or equal to sign. So we're going to use a closed circle, okay? And what we also want to look at is what the inequality is saying. Again, I said refer to your notes from Monday. So that inequality is saying greater than or equal to, meaning I want to put anything that's bigger than -4. And if this helps you guys, if we look at the number line, 0 is somewhere to the right. So that means we want to go towards 0 if we're talking about anything bigger than -4. So the direction of the arrow would be to the right. And another fun shortcut, as long as you understand what you're doing and what the inequality is saying, this helps me, is you can draw the arrow, okay? So this is pointing to the right because it's saying, when I read the inequality, again, it's just telling me x is larger, right, than -4. All right, let's move to this to step 3. What are some possible solutions? So what could I put in for x? What could some of those numbers be? So let's see. Let's start with -4. Could -4 be a possible solution? Well, if I plug it in, I get 9 plus -4 is greater than or equal to 5. If I evaluate that, I get 5 is greater than or equal to 5. This is a true statement because it says or equal to, so yeah, -4 is a possible solution. So anything larger or equal, right? So let's try -3. -3 is larger than -4. So if I plug that in, I get 9 plus -3 is greater than or equal to 5. And if I evaluate 9 plus -3, I get 6 is greater than or equal to 5. That is a true statement. So I could have -4. I could have -3. Oh, Ms. Zelinsky's not very good at writing these, but that's okay. I could even have -2 and so on. These could all be possible solutions. Let's talk about some non-examples or solutions that would not work, okay? Anything smaller than -4, such as -5, -6, -7, and so on, these would not work as possible solutions. So these are non-examples. All right, so let's look at a situation where we have decimals. So we're going to still solve the same way. We've got step 1. We're going to look at the x, cannot graph it because it's not on its own. We have to isolate it first, just like we learned with equations. We're going to apply the same thought process for inequalities. So we're going to use inverse operations. In this case, we're going to add 0.75 on both sides. And I'm left with x is less than -2.15. Now we're going to go to step 2. So we're going to graph our inequality. Again, circle and direction is what we're concerned with step 2. In order to know what type of circle we're using, we're going to look at the inequality. In this case, it's only less than. That means it's going to be an open circle. Okay? All right, we're also going to look at direction. Remember to read the inequality. This inequality is saying it's less than negative 2.15. Okay, that means it has to be smaller. That means we want to go in the left direction, away from 0. We're getting smaller. Okay, so let's talk about some possible solutions. I always like to start with negative 2.15, the actual number that we're graphing. Let's see if it's a possible solution. If I plug it in, I've got negative 2.15 minus 0.75. Again, I like to use the box method. This goes back to your integer operations. If you're not very confident with this, face your fears, make yourself confident. Okay, we're going to add the two boxes. Negative 2.15 plus negative 0.17, sorry guys, negative 2.15 plus negative 0.75. That evaluates to negative 2.9, okay? When I read the inequality, I've got negative 2.9 is less than negative 2.9. That is not a true statement because it is not less than negative 2.9. It's equal. So that means anything smaller. Let's try negative 3. Negative 3 minus 0.75. If I evaluate this, I get negative 3.75 is less than negative 2.9. That is true. Okay, so some examples, you could say negative 3, you could say negative 4 is a possible solution, you could even say negative 5, and so on. Okay, some non-examples is anything larger than negative 2.1. So you can even say negative 1, you could say 0, you could say 1. All of those would be non-examples. These would not work. All right, let's keep going. Here's another inequality where we have fractions. So guys, this shouldn't scare you too much because it's actually very similar from our equations when we had fractions like this in our equations. So let's look at step 1. We've got x over 8 is greater than negative 4. So when I'm solving this, remember, you always have an implied coefficient of 1 if you just have one variable. So in order to understand what inverse operation we're using, we need to look at what operation is presented. In this case, we have x over 8. That's a division problem, right? Fraction represents division. So the opposite or inverse of that is multiplication. And we're going to multiply by the reciprocal, and I'll show you guys why. Off here, off to the side, these cancel. So I'm trying to get my little marker. I've got 8 over 1 times 1 over 8. Okay, if I do 8 times 1, I get 8. 1 times 8, I get 8. If I evaluate 8 divided by 8, I get 1, right? That's why that cancels. So on the left, I'm left with x, my goal, but I have to do the same thing on the right. So I'm going to go ahead and multiply by 8 over 1. And remember, whole numbers can be written over 1 as well. And I get negative 32, right? A negative 4 times a positive 8 gives me a negative 32. So my final inequality would be x is greater than negative 32. So now let's go to step 2. We're going to go ahead and graph. I need to look at the circle and direction of the arrow. We're going to look at the inequality. There's no or equal, so it's going to be an open circle. I'm going to look at the sign. Remember, always look at your sign. Greater than means anything larger. Okay, I keep saying refer to your notes from Monday because they were very helpful. So anything larger means I would go in the right direction towards 0. Okay, so always read the inequality. All right, let's get to step 3. We now need to list some possible solutions. So I always like to start with the integer that we're graphing. So can negative 32 be a solution? Let's check it. If I plug in negative 32 for x, I get negative 32 divided by 8, which is negative 4. So if I read that inequality now, it says negative 4 is greater than negative 4. So that is not a true statement. Okay, that means anything larger. I just went to negative 24 because it gave me a nice clean number. You could try negative 31 because it would give you a decimal and it still work, but I like clean numbers. So if I plug in negative 24 and divide that by 8, I get negative 3. So if I read it, negative 3 is greater than negative 4. That is a true statement. So negative 24, you could say negative 23. I'm sorry, Miss Dolinsky's handwriting is not the best, but that's okay. You could even say negative 22, okay? Let's also talk about some non-examples. That means anything smaller than negative 32. So you could even say negative 32 is not an example, because that didn't work. Negative 33 would not be an example. Negative 34 would not be an example either, and so on, okay? All right, now we come across decimals. So we still solve them the same way. So step 1, we want to get x by itself. Oh, I'm sorry, not decimals. We have a variable on the right. So this, guys, is actually very different. I want you to pay close attention. So we're still going to solve it the same way. I'm going to add 3.2 to both sides. We're getting x by itself. So now we've got 10.6 is less than or equal to x. So if we go to step 2, we need a graph. So if I'm graphing this, I need to look at the circle and direction. But we need to take we got to slow down, we got to halt. Remember, you cannot graph if the variable is not isolated. In this case, it is. However, when I read, because it's so important to read the inequality, this reads that 10.6 is less than or equal to x. I cannot use this inequality because my x is on the wrong side. So I need to put x on the left, but I also need to flip the sign because I told you this inequality has to be facing the variable, or whatever it's facing needs to stay facing that variable or number. So in this case, since this inequality is opening up toward x, I want it to open up toward x as well. So if you guys see that, that's why we flip it, okay? So that means I'm going to have a closed circle, right? It still has the or equal sign at the bottom, but I would actually make the arrow face to the right because this is saying x is larger than or equal to 10.6. These are the same statements, okay? This is saying 10.6 is smaller than x, but this is saying x is greater than 10.6. It's the same thing, but opposites, okay? So that is our graph. Step 3 talks about possible solutions. Okay, so let's start with 10.6. If I plug that in, I get 7.4 is less than or equal to negative 3.2 plus 10.6. If I evaluate the right side of my inequality, I get 7.4. So the way I would read that is 7.4 is less than or equal to 7.4, and that is a true statement since they're equal to each other. So that means anything larger than 10.6 would also work. So let's try 11. So 7.4 is less than or equal to negative 3.2 plus 11. That would give me 7.4 is less than or equal to 7.8. That's a true statement. So you could try 11, you could do 12, you can do 13, and so on. These are all possible solutions, including 10.6. All right, here's some non-examples. Anything smaller than 10.6, like 9, 8, 7, those are non-examples. That would not make the inequality true. All right, guys, that is it for today. I need you to go practice some IXL. You are going to 7th grade, not 6th grade. You're going to complete T4. Since we're using inequalities, I want you to do get a SMART score of at least a 90. I want you to spend at least 10 minutes. Okay, we are having the IXL competition, so challenge accepted. Bye, guys, and good luck.